In Mod 6, we are going to be working with identities. In order to get started with our identities, we're going to recall the Pythagorean theorem. You may have used the version of a squared plus b squared equals c squared. We're going to use the version of x squared plus y squared equals z squared. Remember that x and y are the legs that make up the right angle of a right triangle, and that z is the hypotenuse. Now we're going to move that right triangle into a circle, as you can see in the figure given. The first thing that we will do is replace z squared with r squared. If our triangle is within a circle, then the hypotenuse is also a radius. By replacing z squared with r squared, the Pythagorean theorem now becomes x squared plus y squared equals r squared. The next thing we will do is divide all of the terms by r squared. If we do this division, we now have x squared over r squared plus y squared over r squared equals r squared over r squared. Now, by using the definition of sine and cosine and simplifying, we will get cosine squared of x plus sine squared of x equals 1. Remember that we defined cosine as x over r. So if we have x squared over r squared, then we have cosine squared. Same thing for sine. We defined it as y over r. So y squared over r squared will be sine squared. And then r squared divided by itself equals 1. This is the most commonly used of what we call the Pythagorean identities. Typically, you will see this one written with the sine squared of x first, but it really does not matter which order the terms are in, whether cosine squared is written first or sine squared is written first. The first of the Pythagorean identities, then, is sine squared of theta plus cosine squared of theta equals 1. Or, if we do some algebra on this and subtract cosine from both sides, it could also be written as sine squared theta equals 1 minus cosine squared theta, or do some algebra a different way and subtract sine squared from both sides, and you will have cosine squared theta equals 1 minus sine squared theta. What we're going to do now is take the basic Pythagorean identity of sine squared theta plus cosine squared theta equals 1 and divide all the terms by sine theta. In doing that, we now have sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. So now we are going to do some simplifying and using some definitions of trigonometric functions. By using our definitions and simplifying, we have our second Pythagorean identity. 1 plus cotangent squared of theta equals cosecant squared of theta. Now we can use algebra and rewrite this in two other ways. The alternate forms of this Pythagorean identity are 1 equals cosecant squared minus cotangent squared, or cotangent squared equals cosecant squared minus 1. We are going to take our basic Pythagorean identity again, but this time we are going to divide all the terms by cosine squared of theta. This time we would have sine squared theta divided by cosine squared theta plus cosine squared theta divided by cosine squared theta equals 1 divided by cosine squared theta. So we are again going to use our definition of trig functions and simplifying to get our final Pythagorean identity. The last of the Pythagorean identities is tangent squared theta plus 1 equals secant squared theta. Now, by doing some algebra and rearranging, we have two alternate forms of this identity. The alternate forms would be tangent squared theta equals secant squared theta minus 1, or 1 equals secant squared theta minus tangent squared theta. This is a summary of all the identities we have to this point. First, we have the Pythagorean identities, which we just developed. And then we have our fundamental identities, which we already have used, and you should already know that cotangent is the same thing as 1 over tangent. Secant is the same thing as 1 over cosine. Cosecant is the same thing as 1 over sine. The quotient identities, that tangent is sine over cosine, or that cotangent is cosine over sine. And we have already talked about which functions are even or odd. Remember, the only ones that are even are cosine and secant. Everything else is odd. Now that we have our basic identities, we are going to use these identities in some different types of problems. In the first kind of problem, you will be asked to simplify the expression that you are given, and then use algebra and fundamental trig identities to do so. Once you have finished your problem, the answer needs to be either a number or a single trig function, meaning it must say something like the sine of x or the cotangent of x. There should just be one trig function in it. On example A, we have the cosine of x times the secant of x over the tangent of x. Remember that cosine and secant are reciprocals. So we could think of this as being the cosine of x times 1 over the cosine of x over the tangent of x. Cosine of x times 1 over cosine of x gives you cosine of x over cosine of x. All of that is over tangent of x. Cosine over cosine is 1. Anytime you take reciprocals times each other, your answer will be 1. So you could have skipped both of these steps just by knowing that cosine and secant are reciprocal. So we now have 1 over the tangent of x. Well, this is another way of saying the reciprocal of tangent, and we know that the reciprocal of tangent is cotangent of x. And so that is our simplified form of this problem. On example B, we have the quantity of 1 plus cotangent squared of x times cosine squared of x. The thing that you need to recognize on this one is that 1 plus cotangent squared is one of the Pythagorean identities. 1 plus cotangent squared equals cosecant squared of x times cosine squared of x. So we are just replacing 1 plus cotangent squared of x with what we know it is equal to. At this point, we still have two different trig functions in our problem, so this is not as simplified as the directions want us to be. When I think about cosecant, though, I know that it is the reciprocal of sine. So I can rewrite cosecant as 1 over sine squared of x times cosine squared of x. Now multiply these fractions and you will get cosine squared of x over sine squared of x. We know by definition that cosine of x over sine of x is cotangent of x. So cosine squared over sine squared will equal cotangent squared of x. Now that I have my answer as a single trig function, I have followed the directions and my problem is complete. On example C, we have the problem of cosine squared of x minus sine squared of x times cosine squared of x, and we are supposed to simplify this. All of these problems that we are doing are in preparation for some more complicated proofs of identities that we will be doing later. And so what they want you to do is start to learn to recognize some algebraic types of things in these problems. Remembering that the minus sign is what divides the terms. If we think of cosine squared of x as the first term, and then all of sine squared x cosine squared of x as the second term, so these are two separate items, notice that cosine squared of x shows up in both of those. Let's think back to something like if you had 3x minus 12. You needed to recognize that 3 can be factored out of both of those. And we could rewrite it as 3 times x minus 4. We're going to use the same concept here. What we need to recognize is that cosine squared shows up in both terms. So we are going to factor out cosine squared of x. If you take cosine squared out of cosine squared, what's left is 1. Cosine squared divided by itself equals 1. Minus, take sine squared cosine squared divided by cosine squared, what's left is the sine squared of x. When we start working with these kinds of problems, you need to recognize when you see something like this that it is one of the versions of the Pythagorean identities. 1 minus sine squared equals cosine squared. So we are going to now rewrite this as cosine squared of x times cosine squared of x. So we are really close to what our directions tell us to do. Write it as a single function. We only have one type of function here in the cosine, but we have two different cosines being multiplied. So to make it into a single term expression, cosine squared times cosine squared equals cosine to the fourth of x. And that would be your final answer. As a reminder, I have listed the cofunctions here. It's helpful to try to remember that when you are talking about cofunctions, for example, sine is a cofunction with cosine. The letters CO are always on the front of the cofunction. So cotangent goes with tangent. Cosecant goes with secant. The other thing to remember about these is that the angles are complementary. So if you know one, then the other angle is 90 minus that. We are going to use this idea on our next problems. When I need to rewrite a function as an equivalent expression using the cofunction, first thing I do is just look at which function is it. It is cosine. Well, cosine goes with sine. And then to find the angle measure, you always take 90 minus the given angle measure. So if I take 90 minus 42, then my cofunction is sine of 48 degrees. if you were to actually put these two items in the calculator, you would get the same number for both of them. For example B, we have the secant of 53 degrees. Well, to go with secant, the cosecant will be its cofunction. And then we do 90 minus the given angle measure of 53. So the equivalent expression will be the cosecant of 37 degrees.